When the lockdown began, the first product that was rolled out was hand sanitizer. And we realized that hand sanitizer could be made from home quite easily, but to get the proportions right could be quite tricky and time consuming. So we chose to make a machine that would make this whole process easier, and that's how we came up with Sani. And Sani is a hand sanitizing mixing and dispenser. It contains 5 ingredient chambers, 6 pumps, and then a mixing chamber. So you simply add your ingredients to the ingredients chambers, then the ingredients are pumped to the mixing chamber, and then they are stirred together and then finally dispensed. Our machine is meant to be placed in stores, so the product has 2 different users. There's the customer who uses the sanitizer, and then we have the shop owner that controls Sani through the app.
Martin Christopher here.
We'll explain the app.
When we deploy the app, a timestamp in the initialization defines the needed global variables. This includes creating the array of arrays used for storing recipes and storing the factory default recipe in this array.
The purpose of the main menu is to help the user navigate between the 3 different UI pages. The first one is the Check Status button, which takes you to the status page. In the status page, the current content of each ingredient container shown in %. This is transmitted directly from the MCU. In here, you also find the auto refill button, which activates a global Boolean variable, but we'll elaborate on this later. The status page is also where you register and manage email notifications. We've tried to make this as foolproof as possible. When the email notifications are activated, we utilize this falling edge node that only allows for transmission of a payload whenever the input drops below a specified edge. In this case, it's set to 20 grams. It would be nice if this node allowed for user input, but unfortunately that's not the case. Lastly, we have a statistics flow which displays a graph showing the history of content of the mixing chamber.
The load recipe screen is built around a drop-down menu which contains and displays the name of each saved recipe using a basic index search loop. The 2 core functions of this page are the load and delete recipe buttons, which works quite similarly. Both buttons search the array of recipes for a name that matches the one chosen in the drop-down menu. When a recipe with a matching name in the 0 index is found, the loop breaks. In the load function, the array defined by this index is split into 3 pieces of information saved into 3 global variables used to load the selected recipe. In the delete recipe, the array of this index is spliced from the list of favorite recipes. We use an if statement simply securing that the factory default recipe can never be deleted. If you press load recipe or create a new recipe, you are taken to the recipes menu. Here, the current selected recipe is shown and you can choose to edit the amount of alcohol and oil. When you save a recipe, we use the same function as in the initialization to push it into the list of recipes.
The dispensing of ingredients into the mixing chamber happens once you press this Mix Recipe button. When this happens, the signal is forwarded into the calculations flow. In here, we calculate the amount of each ingredient to be dispensed based on the selected recipe and the weight of the mixing chamber. This is all calculated based on the alcohol percentage of the selected recipe, which is transformed into grams. We also have an if statement checking whether or not there's enough of each ingredient present in each corresponding chamber to dispense the selected recipe. In this flow, we also have a function checking whether or not the auto refill is activated. If so, this falling edge node will forward a signal when the weight of the mixing chamber drops below 50% of the full volume.
All this enables us to send the exact weight of each ingredient to be dispensed into the mixing chamber. This information is sent through the MQTT server to the MCU at the click of a button.
This is the prototype. When the primary user of Sani, the customer at the store or the patient at the hospital, wants sanitizer on their hands, you just walk up and you get it dispensed. The OLED screen shows you information like the weather and the time when it's not informing you that the sanitizer is being dispensed.
And inside the case we have the 4 ingredient chambers, and below them we have the weight sensors, and down below we have the pumps that transport the liquid from the ingredient chambers to the mixing chamber, and down below we have the magnetic stirrer to mix the ingredients, and then we have a pump to transport the liquid from the mixing chamber and then to dispense it through the case. And below the pumping wall we have all the electronics installed. And when dispensing, we press Mix Recipe and the pumps begin. And then each pump continue until the correct amount is reached and it moves to the next one. And the next one.
SANI setup consists of two microcontrollers, one being the Node MCU and the other being Arduino Uno. Connected to the Node MCU is an ESP8266 module, which allows for Wi-Fi connection, and also an OLED screen and two LEDs, which provide user feedback as the user uses SANI. Arduino Uno has multiple pins which allows us to connect actuators and sensors. The pumps are run on 9 volts by using a transistor as a switch, allowing for controlled power supply to all motors. The two microcontrollers are connected by an I2C bridge, which we will go in depth.
From the MQTT server, the different ingredients are then sent to the Node MCU, which receives these with an already familiar callback function. The callback function serves as a constant communication bridge between the MQTT and the Node MCU, which converts the data from MQTT into useful variables. The callback function is being initialized in the setup of the code, but runs independently of the loop function. As long as the Node MCU has a working connection to the MQTT server, the callback function will continue to receive data from the user.
If we want to create a new recipe, the MCU receives a topic and a payload. The topic is the ingredient, and there are 5 different topics, and then the payload is the amount of liquid that's being transferred from the ingredient chamber to the mixing chamber. We want to gather those two informations into one 4-digit number. So let's look at the code. If the topic is ethanol, then the first digit is going to be 1, followed by the payload. Or if the topic is water, then the first digit is going to be 2, followed by the payload. And then we gather all those numbers into an array by to char array. And then we send it to the Arduino with the I2C bridge.
The I2C bridge is set up with the MCU as a master and Uno as the slave. Each recipe is put into an array, which allows for compact and efficient packaging of information. And as seen in the code, one encrypted variable is delivered at a time using a for loop. To ensure that the message is only sent once, the mixing status variable works as a green light for when the recipe is sent. The Uno has 2 functions, one being receive event containing the grams of ingredients, and the other being request event sending the weight of chambers. While pumps are running, request event is paused, allowing for an efficient flow of data on the I2C bridge. The I2C bridge allows both microcontrollers to show their strong suit, as MCU is a connection hub and Uno the control center for a great variety of actuators and sensors.
So the Arduino code receives a 4-digit number. This is E, since the first digit in that number is the ingredient that's going to be transferred from the ingredient chamber to the mixing chamber. We can use if statements to identify which pump that's going to be activated. So if we look at the code, this is the if statements. After identifying the ingredients, we subtract the number we added in the first place in the MCU code. Now the variable E is just the amount of liquid that's going to be transferred from the ingredient chamber to the mixing chamber. So if we look at this picture, we see how the pumps are working. Let's say that the amount of liquid transfer is, for example, 100 grams. This is E. The weight of the mixing chamber before liquid transfer could, for example, be 300 grams. And this is the variable weight start. We also have a variable called weight now, which is constantly being updated. As long as weight now is lower than weight start plus E, the pump shall keep running. And then the pump stops when weight now equals weight start plus E.
To make sure that the pumps dispense the correct amount of each ingredient, multiple weight sensors are installed, one for each of the ingredient chambers and one for the final mixing chamber. The sensors are all connected to an HX711 amplifier, which measures the deformation of the sensors. This deformation can then be converted into a measurement of how many grams of liquid there's currently in the chambers, which then can be used to inform the user of when to refill each ingredient, as well as how much hand sanitizer there's currently mixed. The weights works as shown. By defining a calibration factor and a zeroing factor for both the weights will remember how much weight there's always in them from the beginning on, and therefore also remember how much weight there's supposed to be in when it then turns on and off. Then, when it's actually time for the mixing to happen, it is the weight sensors that control and determines when each of the ingredients has been added successfully from each of the pumps.
Lastly, I would like to show you a CAD model and talk about some of the considerations in our design. The basic idea for our design was that it should be space optimizing, easy to mount each compartment, and that's why we chose a modular build-up, so that the ingredient chamber is placed at the top, the pump wall or the mixing chamber could all be assembled separately and then mounted to the chassis here at the back. Some other key functions are that the compartments for ingredients vary in size so that it's proportional to how much of each ingredient goes in the standard mix. We made the lock function work so that if you turn a key halfway, it would pop up to the refill mode, and if you turn it all the way over, you can take off the cap entirely. At the top, our OLED screen and LEDs are protected by this board, and on the other side of it is this rubber gasket hermetically sealing all of our ingredient chambers, making sure none of the ingredients would evaporate during storage. And here you can see how all of the wires and tubes should be connected in the product. Lastly, here's the product with the measurements that we designed it for. It's sleek and it's easy to have in narrow hallways or wherever it might be fitting. So that's the product. If you have any questions, please ask us in the Zoom meeting now.